write the formula and name of are binary molecular compounds. And these are a ton easier than ionic compounds and even more easier than acids, okay? Because you may want to use the rules for ionic compound naming when formula writing or acid writing, but you don't need to because it's that easy. Then the thing is, though, a lot of people will try to use these rules for the ionic compounds, and then it just gets into a little big mess. So, following these rules will be very easy to do. So, molecular compounds have prefixes, and we use the Greek prefixes to tell us how many atoms are in the compound. So, mono means 1, di means 2, tri 3, like a triangle, tetra is 4, like if you've ever played Tetris. They have 4 block combinations. Penta, like a pentagon, has 5, hexa is 6, hepta 7, octa 8, nona 9, and deca 10. Depends on how nice I'm feeling if I'm going to give you this list on the test. But we may just write it down in our flip chart, so life is good. Okay? So then, when you see this prefix in front of the element name, that's telling you what the subscript is going to be for that exact element. Okay? No crossing, no looking up charges, or anything like that. These prefixes are telling you how it is. So the rules. Molecular compounds contain only nonmetals. We did these in Chapter 8 when we do our Lewis structures and used all of the valence electrons. Okay, so you're going to write the names of the elements in the order listed in the formula, or write the element symbols from the name in the correct order. And you're going to use prefixes to indicate the number. So if it has 2 N's, then you're going to say dinitrogen. Okay? If there's just one atom in the first element, you're going to not put mono, so mono only comes on the second element name, not on the first. Also, like you don't say monoxide, you would just call it monoxide. So if there's a vowel at the end of the prefix, it's usually dropped with oxygen. But that's just a case-by-case basis, and if you don't drop it correctly, I will just help you out there. And then the last thing is, just like in ionic compounds, when we had the second element from the periodic table in our formulas, then the name of it is going to change to IDE. So instead of sulfur, we'd have sulfide kind of thing. We've seen that already. Okay, so let's try some examples and then hop to it. Oh, I had to include this because, you know, H2O, water, symbol for, he thought it was H2O, all the letters. Haha. Alright, so let's do the naming first, and then we'll do the writing of the formula second. So, the first one we have is CO. C stands for carbon. So that's going to be a part of our first name. And O stands for oxygen. But it's second, so we're going to change it to oxide. Alright, now we need to throw in some prefixes. So we have 1 carbon in our formula. So we would put mono in front of it, but as a little precursor for that second rule on page 3, I told you that if just one atom of the first element is in the formula, omit prefix of mono for that. So it's just going to be carbon. And then the second oxygen, we have 1 oxygen. So we do need to put mono for this, but we're going to call it monoxide. So we're going to drop one of the O's. So it's going to be monoxide. So carbon monoxide you've probably heard before. It's released from your car, so that's why you need to have your garage door open before you start your car, kind of thing. It's kind of deadly. So let's get down to the P4O10. P4, well, P stands for phosphorus. And it has a prefix of 4, or it has a subscript of 4. So the 4 prefix is tetra. So we're going to put the whole tetra. So tetraphosphorus for the first word. And then we have 10 oxygens. So oxygen is going to change to oxide. And the prefix for 10 is deca. So we're going to drop the A because we're dealing with oxygen, so we have to be kind of weird. And it's going to be dec, so D-E-C, oxide, decoxide. So tetraphosphorus decoxide for P4O10. All right, now let's read the formulas from the names, using those prefixes to tell us how many. So the first one we have is dinitrogen tetroxide. So we have nitrogen and oxygen are going to be the elements in our formula. It's dinitrogen, so that's telling us there's two nitrogens. So the subscript on the nitrogen is going to be a 2. And we have tetroxide. So tetra is the prefix for 4. So there's 4 oxygens. So N2O4 is the formula for dinitrogen tetroxide. And the last one, iodine heptachloride. We have iodine in this formula. And we have chloride, so that's chlorine. There's no prefix in front of iodine. So that tells you there are one of them. There's one. And then heptachloride, hepta stands for 7. So we're going to have 7Cl. So ICl7 is the formula for iodine heptachloride. That's it. Molecular compounds. Easiest ones in the book.